All right, so we're going to move into a very important part of this unit, and really not just for this unit, but really for the next few years, because factoring, all right, is something that you will use consistently, all right, in most of your math classes, if not all of your math classes. All right, so we've talked about one part of factoring, which is factoring with the GCF. All right, and I should have said that right here in the directions, but I left GCF out. So here's what I want you to do: is go back and think about what we did in a few lessons ago, all right, and find the greatest common factor in parts A, B, and C, all right, and factor those three polynomials that way. And then we'll talk about a little bit more complicated piece of factoring. So go ahead and pause the video, do those three problems, and then flip it back on, and we'll go from there. All right, so remember what we talked about. It's like when I look for my GCF, I'm going to look at my lowest coefficient, smallest coefficient, say lowest, but smallest, and I'm going to start there. So when I think about 18, there's 1 times 18, 2 times 9, and 3 times 6. And I want to find the largest. That's what the GCF means, greatest, right? So I'm going to start with the largest number and see if it goes into the other number. Well, 18 doesn't go into 27, so I can slash that one. Now 9, all right, we know it goes into 18 because I started with 18. It also goes into 27, so that is my GCF for my numbers. Now, when we talked about the variables, what we said is, okay, how many can we take out of each group? So if I have x squared, that's x times x. If I have just an x, right, in the second number there. So what can I take out of both? I can take an x out of both. So that would be the GCF with our variables. Now, if I take a 9x out, remember we're undistributing, which means we're not multiplying or dividing back out, right? So 18 divided by 9 is 2. I had two x's, I took one out, I have one left. Negative 27 divided by 9 is negative 3. I had one x, I took that x out, and so I have nothing left. So there's our GCF. All right, it's 9x, and then 9x times 2x minus 3 would give me my original, all right, expression here. So remember, you always have a fail-safe to check. All right, now, I should finish that statement. You always have fail-safe to check by multiplying back out. It should give you the original, all right, thing that you started with. Now, let's look at part B here. Now, when you look at part B, 5 is my smallest coefficient, and there's only one way to multiply to get 5, and that's just 1 times 5. Well, 5 goes into 25, 15, and 5. So GCF for my numbers, for my coefficients, is 5. Now, when I look at my groups here, right, I have x to the 4th, so that's 4 x's. I have x to the 3rd, which is 3 x's, and then I have x squared, right? So how many can I take out of each group, right, which is always going to be the lowest amount, so that would be x squared. So that means that 5x squared would be my GCF. So now, all right, 5 divided by 5 is 1. I had 4 x's, I took out 2, so I get x squared. All right, negative 15 divided by 5 is negative 3. I had 3 x's, I took out 2, so I have 1 x left. 25 divided by 5 is 5. I had 2 x's, I took those 2 x's out, so I don't have any other x's left. All right, so now when I look at part C here, all right, sometimes you can spot something that may make the factoring just a little bit easier. So for example, I can look at 23. All right, and I know that 23 is a prime number, which means if a number is prime, the only way to multiply it is 1 times itself. So 1 times 23 is the only way to get to 23. So sometimes, and the 5 is actually a prime number as well. So sometimes if you see a prime number as, all right, one of your coefficients, you might want to start there for your GCF, because notice I really only have one choice, and that's 23. And that doesn't work for anything but 23. And that means, so the number-wise, the only GCF I can take out is a 1. Now, when I look at my variables, I have 5 x's, 3 x's, and 8 x's. So the GCF is always going to be the smallest amount I can take out, all right, which would be x to the 3rd. So now when I look at what's left, 23 divided by 1 is 23. I had 5 x's, I took out 3, so I have 2 left. 22 divided by 1 is 22. I had 3 x's, I took out 3, so I don't have any x's in my middle term here. And then negative 12 divided by 1 is negative 12. I had 8 x's, I took out 3, that means there must be 5 left in this group. All right, so now that's factoring, all right, by a GCF. Now, here's the really, really big lesson, and really what we're going to get to, all right? And notice it's discovering these factor patterns, because here's what's nice, is that there are a couple of patterns that will always be true, which will allow us to factor. Now, what are we talking about today with factoring? All right, so we're going to work backwards. So we're going to start with a quadratic expression, and we're going to find the two things that we multiply together, all right, to get that quadratic expression, because we've been multiplying, all right, terms the last couple of lessons. All right, so now we're going to go backwards, and we're going to try to figure out, okay, so what two things did I start with that multiplied to give me this expression? So now, if you look at the next two pages, all right, so if you look at page 20 and 21, So I have given you in your notes here, all right, 12 different, all right, multiplication problems. So you can see x minus 1 times x minus 4, 3x minus 1 times x minus 1, and on and on and on. All right, so 1 to 12 here. So you have 12 different multiplication problems. And you can see that once we multiply all this out, and I use the area model here, we get a quadratic expression every time. So what we're doing today is, instead of doing this problem, which is what we've been focusing on the last few lessons, we're going to start with this problem and say, okay, how can I go backwards to this? That's factoring. Okay, so here's what I want you to do is I want you to pause the video. And there are a couple of big patterns here that I hope you can find, all right, between the 4 numbers in your box and how we get to this answer at the end. All right, so I want you to look at the quadratic expression here, and I want you to look at this box, all right, and all 12 of these, and see if you can see some patterns. So pause the video, look at those numbers for 3 or 4 minutes, and see if you find some patterns there. And then I'll flip that back on and review that with you. Okay, so hopefully, I'm going to highlight a few things here that hopefully you saw in your problem as well. So notice, when we think about working backwards, right? The x squared I see here is the x squared here. The 4 I see here is here. And I end up with a -5, but there's not a -5 in the box, okay? 3x squared, 3x squared. 1, 1. 2x squared, 2x squared. 7, 7. All right. 15x squared, 15x squared. Oh, typo here. There should have been a +2 here. So that should be a +2. All right, so +2, +2. All right. 2x squared, 2x squared. 1, 1. All right. 4x squared, 4x squared. 18 and 18, right? So we can see that every time, all right, and if you were to continue that on all the way through problem 12 here, all right, you can see that every time we do these problems, all right, the first term and the last term are in the first box and the last box. So that was one pattern I was hoping you would see. All right, now here's the other pattern that I was hoping you would see. And if you look at the diagonals and multiply those, what do you get? So when I do 4 times x, I get 4x squared. When I do -1 times -4, all right, I get 4x again. All right, 4x squared. All right, 3x squared times 1 is 3x squared. -3x times -1, all right, is 3x squared. 2x squared times 7, that's 14x squared. -14x times -1, all right, is 14x squared. So the diagonals always multiply to be the same thing. 15x squared times 2 is 30x squared. 6x times 5x is 30x squared. 2x squared plus 1, all right, 2x squared. 2x times 1, 2x squared. All right, that would be 72x squared. 72x squared. All right, and if we go over here, all right, you can see that, all right, when we multiply these guys, all right, we get -4x squared. -4x squared. -30x squared, -30x squared, -28x squared, all right, -28x squared, right? So you can see this pattern, -10x squared, -10x squared, -36x squared, -36x squared. All right, so every time those diagonals in the boxes multiply to the same number. Well, how does that help us? All right, how does that help us? All right, so when we go back and look, okay, so what we have to figure out here, well, we know the first two terms, right? We know the first two terms, x squared goes here, 4 goes here. When we're working backwards, right, we have to now deconstruct, all right? And we have to deconstruct this middle term. We have to figure out, okay, so what gave me -5x squared? Well, it's this diagonal right here. So -1x and -4x, that gives me -5x. -3x and -1x, that gives me -4x. All right. Okay, -1 and -14, that gave me the -15. All right. The 6x and 5x, that gives me the 11x. 2x and 3x, 3x and 24x, right? If I keep going here, all right? Okay, if I keep going, 4x and -1x, that gives me the 3x, right? 13x, 15 minus 2x, 28, -28x plus 1x. So you can see that this middle term, oh, notice here, it's -6x plus 6x is 0. And notice there is no middle term, it's 0. There's no x term. So how does this help us? Okay, two things. What we know is the purple here. Okay, the purple will always multiply to give us the same thing as the blue. The purple also adds to give us the middle term here. And if we know those things, then we can work backwards to factor. All right, so that is the big idea. All right, so now, so if I go back and summarize here, okay, and when I look at this, right, we're always going to know what A and C are, right, because we saw that. Okay, so we know ax squared goes here, right? So we said the first term and the first term, the last term and the last box. So we know those go together. Now, what we know is that if I multiply A times C, that has to give me the same thing if I do these two guys, and that's why we have M times N here. So we know when I multiply these two guys, right, it has to give me the same thing as A times C. And we know from all those examples, all right, that these two also have to add, be that middle term right there. So that's our pattern, each and every time. So let's look at a couple of examples to kind of put that together. All right, so now we're working backwards, right? We're trying to find these two binomials that multiply together. All right, so now when I look at my first problem here, what I know, right? I'm gonna see if I can get this all in the same view here, is I know my first term always goes in the first box. We saw that with every pattern. We know my last term goes in the last box. We saw that with every pattern. All right, so now what we know is that when I multiply these two guys, it's going to equal the same thing here. Now, I'm just going to look at the coefficients. We don't need to get to the x squared part, but I'm just going to do 5 times 1. All right, so I'm going to do 5 times 1, and that's 5. So I'm going to do A times C. And then so what I have to do is now I have to find two numbers that multiply to be 5, but then they have to give me this middle term here. They have to add to be 6x. All right, so now I think about the ways to multiply get 5. Well, 5 is prime. There's only one way to multiply 5. Is 1 times 5. Well, notice 1 times 5 is 5. 1 plus 5 is 6. So if I have 1 times 5, that's 5, and then 1x plus 5x, all right, then that gives me a 6x. And these are the two things that we're missing here. So here's the 1x, and here is the 5x. All right, now here's why the opener was the greatest common factor, because, right, now we have to go backwards, and we have to find the GCF in each column and each row. So when I look at my first column here, the biggest number that goes into 5 and 5 is 5. All right, they both have 1x in common, so I can take out 1x. The largest number goes into 1 and 1 is 1. And there's no x's in common, so I can't factor out an x. When I look at my first column, or my first row here, the biggest number that goes into 1 and 5 is 1. They both have 1x in common. I can take that x out. When I look at 5 and 1 again, the largest number I can take out is a 1. So what is this telling me now? This means I must have multiplied 5x plus 1 times 1x plus 1 to get 5x squared plus 6x plus 1. So that's the combination. And once again, if we look at this pattern, 5x squared times 1 is 5x squared. 5x times 1x, that's 5x squared. All right, so you can see that it's that same pattern every time. Okay, let's look at problem 14. All right, so once again, the first term, first box. Last term, last box. All right, now let's do A times C, right? So we're going to do A times C. So 3 times negative 2 is negative 6. And so that means whatever I put here and here has to multiply to be negative 6, but it also has to add to be our middle term here, which is negative 1. All right, and I can maybe put those x's on there so we can try to see, make sure we get to the same thing. So 5x squared there. All right, so now when I look at negative 6 here, and we want this to be negative 6x squared. Now, I'm getting to a negative number when I'm multiplying, so that means I need one positive number and I need one negative number. So when I think about the ways to multiply to be negative 6, right? I can do negative 1 times 6, and I can do 1 times negative 6. All right, and if I add that, that's positive 5, and if I add that, that's negative 5, but I gotta get to negative 6. So now I can do negative 2 times 3, and I can do 2 times negative 3. Well, negative 2 times 3 is negative 6, but negative 2 plus 3 is a positive 1, so we're really close. Then I can do 2 times negative 3, that's negative 6, and then 2 and negative 3 would be 1x. So if I have 2x times negative 3x, that's negative 6x squared. And then 2x plus negative 3x, that's negative 1. So I can drop those two in. And once again, it doesn't matter. You can put this in either box. Okay. If you put the negative 3x here and the 2x here, you'll get the same answer in the end. It just changes where it's at. Okay. So that'll just flip what you have here and here. So now let's look at that GCF. So when I look at my first column here, the biggest number that goes into 3 is 3. They both have one x in common, so I can take out one x. The biggest number that goes into 2 and 2 is 2. They don't have x's in common, so I can't factor in x. 3 and 2, the biggest number I can take out of 3 and 2 would be 1. They both have one x, so I can take out one x. All right, now when I look at this one, notice they're both negative, so I can take a negative out of that. The biggest number that goes into 3 and 2 is a 1, and they don't share any x's, so I can't take any x's out. So that means I must have started with 3x plus 2, all right, times x minus 1. And once again, if you were to multiply this out, all right, like we've done before, you should get your guy right here. All right, let's do one more together here. Let's look at number 15. All right, so once again, looking at our pattern, first term, first box. Last term, C term, in the last box. So when I do A times C, I get negative 35x squared. And that has to add to my B term, which is negative 2x. All right, so now I think about the ways to get 35. All right, so I can do, and once again, I'm multiplying to get a negative, so I can do 1 times negative 35, all right, or negative 1 times 35. Well, when I add that, I get negative 34 and positive 34, so not quite. And there's only one other way to get 35, which is 5 times negative 7, right, or negative 5 times 7. And I need to get to negative 2x, so now, a 5 and a negative 7, that gets me to negative 2. So I want 5x and negative 7x, that's negative 35x, and then 5x plus negative 7x is negative 2x. All right, so drop those in. So I'm going to drop the 5x in here. I'm going to drop that negative 7x in there. Now, once again, we're looking for GCF in each row, each column. So when I look at the column here, the biggest number that goes into 7, and 7 is 7. They both have one x in common, so I can take that x out. The biggest number goes into 5, and 5 is 5. They don't share any x's, so I can't factor out any x's. When I look in my first row here, the biggest number that goes into 7 and 5 is 1. They both share one x, so I can take out one x. Same thing here, all right? I can take out a negative, and the biggest number that goes in 7 and 5 is 1. They don't share any x's, so that's it. So that means I started with 7x plus 5, all right, and 1x minus 1. And there's our factor. Now we're going to keep doing this, and the great news is once you memorize this and know this, it's the same factor pattern all the time. You'll use this again and again and again. It's not going to change. All right, it's not going to change. The only thing that changes is complexity, because the larger this term gets, maybe the more combinations I have to search before I find to get my B term. All right, so if you have any initial questions, make sure you highlight those, have those ready for class, and we'll do a little bit more factoring when I see you next time. All right, take care.